So now let's jump straight in. We're going to get started with a fireside chat with Johannes Gehrke, and the managing director of Microsoft's research at Redmond. Before that, he was leading architecture and machine learning for IC3, which is the Intelligent Communications and Conversations Cloud, which powers Microsoft Teams. Before that, he was a professor at Cornell for many years. And before that, he was completing his PhD at University of Wisconsin, which I actually just recently learned and is really cool because that's where I did my PhD. So go Badgers. Johannes's main research interests are in database systems, distributed systems, and machine learning. He's received a litany of awards over the years, including the National Science Foundation Career Award, an Arthur P. Sloan Fellowship, a Humboldt Research Award, an IEEE Computer Society Technical Achievement Award, among others. And I'm really excited for him to be with us today for this fireside chat. Johannes, welcome.
Thank you, Sean. So it's great to be here, and I just wanted to welcome you to this third AI breakthrough event. It's really unfortunate that we cannot see each other in person, but I'm looking forward to engaging with you in smaller groups throughout the day. And I also wanted to thank Daniel and Sean and the team for organizing the event. So I wanted to give you a little bit of background before going into the fireside chat. And I wanted to actually step back and look at Microsoft's mission, because this is actually a mission that I fully subscribe to, and it's clearly a mission that's very actionable. So first of all, there's a focus on innovation, right? We believe that technology should be a force for the good, and that a lot of meaningful innovation can contribute to making the world better in small and big ways. And with Microsoft Research, of course, playing a really big role. There's a huge focus in the values of the company on diversity and inclusion. The mission by itself is very inclusive: empower every person, every organization on the planet to achieve more. So this means that we expect all of us, independent of what our role is, what our level is, what our function is, whether we're at MSR or not, to really play an active role in creating an environment where everybody is excited to bring everything of what they are and who they are to do the best work. Another focus that you may have seen in the press a lot recently about Microsoft that I'm really personally excited about is social responsibility. So there's a variety of programs at Microsoft that we as Microsoft employees, and of course at MSR, can contribute and engage in and play a crucial role. For example, one of them is sustainability, where over the last year, Microsoft has committed to becoming carbon negative. You probably have heard about this. It's really becoming a zero waste company that is building a new big compute platform to look at the Earth's natural system. And now actually the pledge that came out yesterday was to become water positive by 2030. And that means that we'll replenish more water than we'll use. And I think it's just these kind of commitments that, for me at least, put the mission into action. There's, of course, also a big commitment to accessibility, right? That especially for the tools and everything that we're building, we focus on also people with impairments to vision, hearing, tools for learning. Has 8 labs, over 1,000 scientists, a lot of really famous people here. And it really spans now across the world. So it's, we're clearly here in research at Redmond, but we have 3 other labs across the US, and then of course a lab in Cambridge, and then labs in Beijing, Shanghai, and India. And there are, each lab sort of has its own culture and its own focus, but there is a lot of collaboration across the labs. There are projects that span Redmond and Cambridge and Beijing, and then it's often hard to actually find a time zone where everybody can make it. For example, this week, there's a workshop happening across AI for software engineering that I'm a part of. And actually the workshop happens one day early in the morning and the next day late in the evening to sort of be an equal opportunity offender for everybody. Basically what these labs allow us to basically look at a diversity of different approaches in the frame of our mission, but then really connect across the company. And especially since also our development is not only local here in Redmond, but is also spread across the world. Every lab can also engage with local product groups to have even closer connections. Last, I want to say a little bit about our research styles, because They go all the way from purely curiosity-driven research to more mission-driven research. So in curiosity-driven research, we really have, it's called sometimes also Horizon 3, so really long-term research. It's purely based on curiosity of an individual researcher. So we look into the future, we envision what the future could be, we prototype interesting, cool things, like in our HCI team, there's really amazing work going on. We try to solve the really hardest problems and sometimes don't make progress for years at a time, but then come up with breakthrough. And this is really what the company has funded us for. The company wants us to preserve the future for Microsoft and therefore look ahead. But then some of these projects, they also move ahead and we solve some important problem, we actually make a technology breakthrough, and then actually they lead to very short-term, mid-term, immediate, tangible, really high impact on our business. And that's also what excites me. I made, I can talk a bit more about this later on, but I made a detour where I started out as a professor for a while, and then I was actually in a product team for 7 years, and now I came back to research. And it's really interesting to look at the interplay between research and product. And that's one of the things that Microsoft is really strong at. And we're really proud of the great collaboration between MSR and our product teams. So with that short framing, I'm really excited to looking forward to interacting with you. And I'm looking forward to the Fireside Chat now.
Great.
Back to you, Sean.
Thank you, Johannes. Yeah, so let's get into the Fireside Chat portion. So you already kind of hinted at this a little bit in your remarks just now, but I was wondering if you could start a little bit by telling us kind of about yourself and about your personal journey through academia, through industry. You kind of have a unique journey, I think, that's kind of very MSR in a way, being academic and in industry. But I'm curious, kind of, how did you get into research originally, and kind of how did you end up where you are now as managing director of research at Redmond today?
Yeah, it's so I was always, as a child, I was always fascinated by technology and computers. I was always a tinkerer. I loved to program already in middle and high school, and then computer science was a natural way or the natural subject for me. As a student, I got early on exposed to research. In Germany, you can sort of go into a research group and they pay you to do some programming. And there was actually a database group in Germany. And that's where I sort of learned to love the problems in the database systems area, where you have this really beautiful, often high-level declarative language that only says what you want, but not how it's actually being computed. And that then translates down through a query optimizer and then very efficient query processing technologies to really scale out to hundreds of nodes. And in a way, for a long time, I would say that SQL is probably the most successful parallel programming language, because you're actually completely isolated from all the parallelism that's happening. Then through a detour, I ended up as an exchange student in the US and got stuck here. And I ended up in Wisconsin, where I did my PhD. My advisor, interestingly, is now also here at Microsoft. He's the CTO of data, Raghu Ramakrishnan here. But then I went to academia, and I was really lucky to get a job at Cornell. I mean, Cornell was just really a fantastic place. It's a very collaborative department. I really had the privilege of working with a fantastic group of PhD students. Over time there, I was there for close to 15 years, and I graded 25 PhD students and worked with 6 postdocs. So it was just a really amazing group that we had. They are both not only in the database area, but across the whole faculty. I don't know, if it would be live, I would ask whether any Cornellians here in the audience. But
yeah, we have some, I think. Yep.
Yep. And at Cornell, what I worked on was a lot of core database problems, but less in the core of database systems, but more applying database ideas to other problems. For example, I started to work out in sensor networks, where we thought of the distributed sensors in a large-scale sensor network as mini database systems that each will hold a table with the sensor readings. And then we looked at query processing techniques that spanned ad hoc networking and query processing. I worked on data stream processing. I worked on a lot of scalable data stream algorithms. And then I also worked on data privacy, which actually came from an interesting connection with the government, where after 9/11, we were selected to look at technologies that could help the government to integrate across different government agencies with a very strong interest of actually preserving privacy. And so then I discovered differential privacy, which was, of course, here pioneered at MSR by Cynthia Dwork. And my group actually developed the very first public data set together with the Census Bureau. This is called On the Map. And this is actually the very first public data set that was ever published that had formal privacy guarantees with it. It actually had a version of epsilon delta differential privacy. And in between, I was part of a startup. It's a Norwegian startup. It's called Fast Search and Transfer. Some colleagues introduced me to it. I was chief scientist at this company. And the company was acquired in 2008 by Microsoft. So this is actually the first time I actually got a Microsoft Blue badge, which is sort of the badge for a full-time employee. But then I went back to Cornell. And then in about 2013, some of my friends in that company and I, we had another idea. And the idea was that Fast, the company, was about enterprise search. And enterprise search, in a way, was always much worse than internet search. And the reason for that was that in the internet, we're signal rich because the world's population is going after the same corpus of data. In addition, the corpus is also very rich in that we have, reputation of sites, we have links between sites, and, of course, now we have many other signals. In the enterprise, traditionally, enterprise search is signal poor. Enterprises have vast collections of documents, but very few employees. There are very few searches within a company. So the relevance of enterprise search was always a problem. But now, as Office 365 moved into the cloud, and that sort of was happening in a few years before that, suddenly even enterprises or enterprise search has become signal rich. For example, right now, Sean, the two of us are here in the same meeting. This actually now creates an edge between the two of us. And so therefore, the documents that I've created are maybe a little bit more relevant for you. So what we built is a data asset that we called the Office Graph at that point in time. And it basically took all of the signals that Office 365 created and first of all made them available to individual tenants through an API, but then also used them to make enterprise search and a bunch of other applications. We built an application called Delve, which is more like a relevance feed for you, and made all of these much better. And at that point in time, then I was thinking, should I return to Cornell or stay here? And Microsoft was just such an exciting place in terms of data, in terms of collaboration, in terms of scale. And so at that point in time, with a heavy heart, I decided to leave Cornell and stay here at Microsoft. Then I worked on Microsoft Teams, and I was the chief architect of the backend, and I was leading AI for Teams for a while. For example, we rebuilt large parts of the infrastructure with the modern Azure architecture, and that was really a lot of fun. And then when about 4 years, I was presented with the opportunity of whether I would be, interested in coming back to MSR, I didn't think twice. And I was just really excited about being here, and it's been really a privilege to work with everybody here. MSR is just a fantastic place. It's a place where we have ring-fenced resources to look really at the future of the company and preserve the future of the company, but really also of society. And so I'm really excited both by, Microsoft's mission, how it applies to MSR, but also in general, how, Microsoft Research works as an entity.
That's great. Well, it's so great to have you here at MSR these days. I'm curious, so your background started mostly in databases, distributed systems, and that's kind of, you're an expert and one of the world's foremost experts in those areas. And it seems like probably kind of machine learning and AI sort of crept in to the work and became maybe a little bit more important over the years. I'm curious, like how did machine learning sort of start to enter the equation for you and AI more broadly?
Yeah, so my thesis was interesting in what's called data mining. And so this was basically taking some machine learning algorithms and really scaling them up to very large data sets. And I was always interested in the interplay of data and statistics.
Gotcha.
Now here at Microsoft, I just saw the power of machine learning in many real-world applications. I mean, if you look at Teams, many of you may have used background blur. We're in the process of rolling out noise suppression. I talked already about our strategy of taking the media stack of Teams and replacing it with machine learned components. So there's basically just the power of machine learning, the power of AI in real applications, especially right now, where you can take individual components and take them and replace them with AI is just really powerful and just gives us much better performance than human written rules. This is actually happening, for example, also in database systems, interestingly. There's now a really interesting set of research that looks at replacing the control plane of database systems with machine learning. So if you think about database systems, again, they're sort of a data plane and a control plane. The data plane is basically, we have the data plane, we have the query plan, and we let it run. The control plane is about, here's the SQL, and what is the actual query plan that we're using to execute it. And that was traditionally done through a combination of dynamic programming and various search strategies that people have tried out. And now the search strategies are happening, for example, through deep reinforcement learning, where over time you both discover the statistics that you need to decide on the best plan, as well as what parts of the plan search space you should explore. And so that's really exciting. I think more and more parts of a database system that are sort of more on the control plane will be replaced with AI as well.
Interesting. Cool. Well, so the name of the event is AI Breakthroughs. And so I was kind of curious to learn about what you think about in terms of what are the most important and exciting, moonshots for research in AI. They're often called moonshots. I mean, I'm also kind of curious, how do you even think about moonshots in general at MSR? Is that just a metaphor for doing ambitious research? I'm curious what you think about, like, what are the most important and exciting breakthroughs or moonshots, and how they might have a positive impact on people, on society, and on the planet.
Well, that's a big question. So let me take it sort of piece by piece. So I think first of all, I'm not an expert in AI, so what am I to tell you? But I think what I've seen a lot is what AI can do. And so I think even one exciting moonshot is to take AI and make it really work for some high value real life scenarios. For example, if you look, there's huge societal benefit if you look at healthcare, education, transportation, productivity, just to name a few. For example, productivity, you could imagine that, I don't program alone, but I have an AI pair programmer. You could imagine that I don't write my document alone, but I have a coach, an AI coach. It's like the PowerPoint presenter coach that we currently have that gives you feedback on your presentation. And of course, these are specialized examples, but I think there's very often a big gap between the AI that's being, or the machine learning that's being published in papers, and that's applied to very specific scenarios than to actually make it work in practice. And so, is that a big moonshot? Maybe not, but I think it actually is something that would make a really big difference. Another moonshot, I think, maybe to look at and to understand how machines and humans can deeply collaborate. You saw that already a little bit in the examples that I had before, where many applications of AI have been really trying to replace a full human. So maybe in self-driving cars, or maybe really relieve humans of microtasks, right? I don't have to compose a full world anymore in a sprint reply to my email because, a model predicts what I'm going to say anyway. But in general, I think there are a lot of really interesting challenges as people and AI collaborate. Again, let's go back to the healthcare scenario. One example is transfer of control. Again, in the email scenario, it's super easy, but assume we do this in an education scenario, right? What does the student do, and what does the AI do so that the student will actually learn something and doesn't only give the AI enough hints? How do you do this in a healthcare scenario? What does the doctor do, and what does the AI do? How does the doctor transfer, control to an AI and also back? Is it more like a teacher or student, or is it on equal footing with the AI actually being creative? And I think this also means that we need models to explain that they're making certain choices, and humans can understand the inference of the next steps. Another good example of this collaboration is also cognitive tasks, right? So I think cognitive psychologists have worked for a long time on characterization of the human mind. And AI could help us to augment human cognition by understanding human weaknesses, in health and illnesses and mental illnesses, for example. They could remind me of things that are likely to forget, make better decisions, or have a better focus of attention. I don't have to meditate anymore every morning, but maybe the AI helped me to automatically stay focused. And then there are lots of course, interesting technical problems. I'm sort of talking more application areas, clearly in training and inference. Right? Brains are supposed to be, maybe order 10 to the 5 more energy efficient than our current models. GPT-3 is really big and really interesting, but it's also so expensive that it's hard to deploy for any real applications. So how do we create models and training, and so training and inference that we can actually afford and that we can deploy at a wide scale? And this then also goes all the way to theory and algorithms, right? I talked about the problem of finding new ways of reducing energy, scaling up to the next gen data center. I mean, a high level calculation would be a data center maybe has 60 megawatts. Let's assume a neural processing unit will take 60 watts. Well, then maybe in the next generation data center, I'll have order 10 to the 6 NPUs or order 10 to the 5. How do I scale, my training up to that level of NPUs, neural processing units? So these are all interesting questions that I think are, moonshots for AI and for AI applications.
Yeah, and for all of those breakthroughs and other areas, it seems to me that MSR is a pretty special place to be working towards these. I mean, that's why I'm here, and I'm curious what you think about what makes MSR that kind of special place, and particularly thinking about all of the opportunities internally with other groups at Microsoft product teams, but also externally with partnerships, universities and other institutions to kind of make progress together towards these big achievements.
Yeah, so it's a great question. So first of all, I see MSR as sort of a huge playground for creativity and freedom and impact. I'd really had the privilege over the last 3 months of really going on a learning tour of learning about all the projects. I mean, Sean, I learned so much about your research on Psi from you. That was really exciting. So first of all, I think it's really an amazing place if you want to be a creative researcher. I think, and that coupled with the mission of the company and the ethics of the company, and then also really the resources and the partnerships that we have across the company. Again, I'm coming from a product team. While I was in a product team, actually, we had a research project that was led across product and across Microsoft, research at Redmond, across MSRA and MSRI. And some of that was more short-term, and some of that was really very, very long-term research. And so I think just being able to partner with product teams where suddenly you have an idea and then you see it grow and have an impact on, millions and millions of users, right? I mean, the work in teams that we did is now, impacting everybody, both from, small people to big people in terms of, education, healthcare, mobility, work from home and everywhere. So I think having that kind of impact and having that kind of possibility at Microsoft just makes it a very special place. And maybe the last thing is, so wherever I've worked, one thing I really cared a lot about is that, are there actually good people there and people that I would get along with? And that's the other thing that I felt about MSR is that we just have a really fantastic set of people that are collaborative and open and really interesting in new ideas.
Yeah, that's great. Yeah, really good people here. I wanted to get to one of the questions from the Q&A. We have about 5 minutes left because I think it's a really good question about kind of advice. So they're asking about do you have any tips for those deciding between careers in industry versus academia? And a related question, kind of how difficult is it to switch from one to the other at a later point in time?
Right. No, it's a great question. Industry and academia, I think, is quite different. So if you go to academia, basically you are on your own. So you think of yourself as the CEO of a small company. So I remember when I joined Cornell, and I was sort of asking around, what do you need to get tenure here? And they said, well, to get tenure, you need to be famous. Do you have to write a certain number of papers? No. Do you have to get a certain number of grants? No. Just do whatever is necessary to create the most impact. Right? And so they gave me a desk and a little bit of money and said, good luck with that, right? And I think that's an amazing opportunity, right? I mean, so if you have that level of entrepreneurship, if you have that level of ideas also, I think that's the most important thing. And if you feel like you have all the independent ideas that you want to do this, academia is a great place, especially, you have amazing students that you can work with. So I can only say positive things about academia. I think here at Microsoft, the place is a little bit different in that you could do exactly the same thing. But you also have, and by the way, we value that a lot, but you also have the opportunity to join other projects and to do something much bigger than you could do with a few graduate students, and to partner with product teams and to learn about problems that people care about, because a lot of the product teams, as well as a lot of people in MSR, they have very deep knowledge of the industry and where industry is going. And therefore working on problems that are not only technically interesting, but where there's also a possibility of then actually shipping them and seeing them in a product and then in a way really touching them. That is also really exciting and can be very satisfying. So I think both of them are really good places. We see more and more people moving back and forth. So we see people from MSR, they've been here for some years, they move back to academia. And we've seen people who come from academia, like myself, and go to industry. So I think in both cases, there is movement across. Here at MSR, clearly we are, open clearly to publication, and it's strongly encouraged. And our people publish in the top conferences, get PIS paper awards, and talk about all the great work that's going on here. But in addition, I think the other point of impact that we can make here is that we can touch the product groups and therefore indirectly touch the hundreds of millions of customers that Microsoft has all across the world.
Great. And I wanted to ask one more question, and there was one more question in the Q&A that kind of merges with one of mine. Thinking, kind of zooming in like on a successful project at MSR, the components that make a successful project. Obviously, there's no one answer for that. There are projects at many different scales. But I'm wondering how you view kind of not only what are the components of a successful project, but someone asked sort of how do research projects typically get initiated at MSR? Are they kind of is it a team-based process, or do individual researchers have the freedom to initiate their own projects?
Yeah. So the answer is all of the above. So first of all, individual researchers have complete freedom to initiate their own projects. In addition, sometimes product groups come with us with some crazy ideas, and we say, hey, maybe this is not really the right idea, but we could do this other thing. And it becomes a great partnership. There's actually a lot of discussions about what the future could look like within MSR here, and where we make maybe certain bets. What is the future data center going to look like? What's the future of the AI infrastructure going to look like? What are the future really high impact applications that we could have? And then we try to team up across different teams at Microsoft Research to really make something work. Some of the most impact projects that we have, they're not only in database systems, but they're in database systems and involve a bunch of people from machine learning. They're not only in systems, but they involve systems and machine learning. They're not only in HCI, but they involve HCI and machine learning. So I think especially this cross connection is something that I think we at Microsoft Research are especially good at. And then of course, there's the other, unfair advantage that we have at Microsoft. We have a ton of data. We have, all the product groups. We have a huge amount of compute available to us. So I think these other structural advantages are also things that are there at our availability to use.
Great. Well, I think that's a perfect place to leave it. So thank you so much, Johannes, for being with us this morning.
Yeah, thank you. Thanks for the invitation.